This 3-mark question asks us to rewrite a fraction which involves surds in the form of a plus b root 2, so as a simple surd where a and b are integers, a and b are whole numbers. So the process here, I'm going to start with writing down my fraction. And just so I don't go wrong, I'm going to put parentheses, put brackets around the numerator and the denominator. I have to treat them as complete things, complete terms in themselves. And what I'm going to do here is I'm going to multiply by the denominator, but I'm going to change the sign. So the sign inside my denominator is negative, so I'm going to change it to a positive. Now this is called rationalizing the denominator. And it's a process where you can actually get rid of the surd at the bottom of my fraction. So what I have here now is, if you know when you multiply two fractions, you multiply the numerators together and you multiply the denominators together. So at the top here I'm going to multiply 4 plus root 8 by root 2 plus 1. So what does that give me? Well, the 4 multiplies the root 2, so I have 4 root 2. And 4 multiplied by 1 is 4. Then I have root 8 multiplied by root 2. And I'll have just root 8 multiplied by 1, which is root 8. At the bottom here, I have root 2 multiplied by root 2. Then I have plus root 2, because root 2 multiplied by plus 1. Then I have minus root 2, so that's minus 1 times root 2. And then I get minus 1. Well, minus 1 times 1 is minus 1. Clearly you can see here that these two terms here will immediately cancel. Plus root 2, minus root 2 would cancel each other out. Now let's tidy this up a little bit. We'll start with the top. I have 4 root 2 plus 4. Now root 8 times root 2 is the same as root 8 multiplied by 2. I can combine those within a root, and then I've got plus root 8 afterwards. Underneath I have root 2 times root 2, which is just 2, and I am taking away 1 still. So here now you can see that the denominator now will just become 1. 2 take away 1 is 1, so I don't need to put it as a fraction. I will put it as a fraction for now, but I don't need to. 2 take away 1 is 1, so that just means my fraction is now gone. And what have I got here? I've got 4 root 2 plus 4 plus the root of 8 times 2 is 16 plus root 8. That then becomes 4 root 2 plus 4 plus the root of 16 is just 4. And root 8, well, root 8 is the same as the root of 4 times 2. And this is all over 1, so my fraction is now gone. Moving on, I'm now going to do 4 root 2 plus 4 and 4 is 8. And then my root 4 times root 2 is the same as 2 root 2. The root of 4 is 2, and my root 2 stays the same. And finally, now let's just rearrange and simplify. I'll put my whole number at the front, so that's 8, and then my surd part at the back, which is 6 root 2. 4 root 2 plus 2 root 2 is 6 root 2, and that is the answer. So what we've done, just to recap, when you have a situation like this, you always multiply by the denominator, top and bottom, but change the sign. If this was a positive, we would have written negatives here. Because this is negative, we make them both positive. And by doing that, you can see when you multiply these two brackets at the bottom, that the surd part, the root 2 part, disappears, and the other two root 2's combine to make it into an integer, and then things follow through. At the top, what you will try and do is rearrange it, and then look for where you can combine to make whole numbers. So, for example, 8 times 2, that's going to give you root 16, which is just 4, it's just an integer, which is nice. And then you have this root 8, which you need to combine into 4 and 2. And you're looking at that because the question said it had to be root 2, so you know that every time you've got one of these surds, you're going to have a root 2 within the surd element itself.